tradition finds itself at odds with progress, edging ever so close to an inflection point. One that has been gradual and yet sudden. Because change is not about the next trend. It is about the next generations.
All right. Thanks. Good afternoon, everyone. Welcome to the last segment of Substance Days at GDC 2023. This is Advances in Uniform Creation for EA Sports NHL. My name is Gary Snyder. I'm a Director of Technical Art at EA Sports Vancouver, and I'm the Supervising Technical Art Director for the NHL franchise. This is my first time at GDC in just about 20 years, and it's my first time representing NHL in the last 7.5 years that I've been on the team. We thought it'd be fun to share a little bit more about ourselves before we get into it. So I grew up in Texas, and we didn't even have a hockey team until just before I left for Canada. I've been in the industry that long. All I knew of hockey was growing up was from Nintendo Ice Hockey and Blades of Steel. So I didn't even really know much about the sport coming into it other than it makes for some great action games, that's for sure. What we have here, though, is one of my favorite moments from when we were on since when I've been on the team. We sometimes have the opportunity to go out to these pro stadiums and capture a lot of data. We'll scan them, we'll get light probes and get all this authenticity data that we bring back to the game. And I had the chance to stand at center ice at Rogers Arena in Vancouver, which is home to the Vancouver Canucks. And so it was really fun. We turned up the game lights and we each took turns standing at center ice and just generally having fun while we got to take over the stadium for a few hours.
And I'm Dallas Finerty. I'm the Associate Character Director on NHL. This is my first time actually being at GDC, let alone presenting at it. So it's been a pretty fun experience so far for me. I've been on the NHL dev team for roughly 14 years. I've played the game a lot longer than that. I grew up playing hockey from around the age of 3 years old. And I kind of started playing the game in the early 90s, probably around like NHL 93. And I've kind of just, it was part of kind of hockey culture as we were kind of growing up. So I've played pretty much all of them. It's been a lot of fun kind of working on this team. It's obviously hockey is my passion, and we get to do a lot of really fun stuff. Like the photo you see here, just a few minutes away from where we're at now. We got a chance a few years ago to go scan another arena, San Jose Sharks Arena, like Gary was saying that we do occasionally. It was pretty cool. We got to go around the whole building and just take reference shots, and they had the shark head on the ice you can see behind me there, which is massive, by the way. It's like probably 3 times my height. It was pretty cool to see. We're really happy to be here, and thanks to Adobe for inviting us to come speak. Let's get into it.
Yeah, all right, thanks, Dallas. So that video that we opened with was our worldwide reveal for NHL 22. And that ended up being a huge year of firsts for the franchise. It was our first year on the Frostbite engine, which was once exclusively known as the Battlefield engine that powered our first-person shooters, but now it's being used by almost all of our sports titles. It was our first year on the new generation of console hardware, and with more power comes much bigger expectations. It was also our first year actively developing for 2 console generations simultaneously, which roughly doubled the number of platforms that we needed to support, and the 2 generations had a pretty wide gulf of capabilities between them. So we had to balance that power versus performance a lot. And like a lot of other people that were here, it was our first year developing NHL fully remotely thanks to COVID. So if you couldn't tell, the NHL team loves a good challenge. That's a lot to stack up in a single year. So we figured what better time to build a new workflow for uniform and apparel creation from scratch than this particular year. And when we talk about a year, we're actually talking about 9 months because that includes everything from pre-production to filing. So short time, a lot of work to do. We got down to it and we started talking more and figured that this mythical workflow would also need to be robust enough to carry the team into the future, as in beyond the now current generation of new consoles like the PS5 and the Xbox Series. So we had to think bigger and farther ahead than ever before. Another thing about the NHL team is that we're incredibly passionate about the sport. We have a lot of folks on the team who have been there multiple years, like Dallas. They play on teams in their local leagues. They coach for their kids' team. We even have some folks who use their love of the game as a means for community outreach. So for us, this was about more than just moving to new hardware or adopting new technology. It was an opportunity to express all that passion and experience in new ways using the new tools at our disposal, because we haven't really had a kick at the can for doing this since about 2015. So that's a long time, and tools change quite a bit. And this brings us to the Substance Suite, which we use to help build that new workflow. So Substance Designer's flexibility gives our technical artists the tools to build a scalable framework for content creation, while Substance Painter's interoperability with Designer, combined with its intuitive interface, helped our art team build and grow a high-quality, reusable, and reconfigurable asset library. And together, they helped empower our team in constructing the most authentic and detailed uniforms yet across the widest range of platforms ever for the franchise. So while most of the team was busy getting the NHL working on Frostbite, a small strike group of us started developing some concepts for what would become our next-gen workflow, uniform workflow. We have an ongoing partnership with various professional leagues and teams on hockey, and that meant that we had access to years of official uniforms and league reference, and that came in very handy for what comes next. We started off by going through that reference material and our existing uniform source art, looking for the right set of assets to build our concepts with. Our source art already had some of that vector art embedded in it, and we thought, what if we could use some of this content that we already had on hand as a way of future-proofing our future uniforms? We also hit on this notion of physically based construction to mirror the big move that we were making to physically based rendering that we were embracing as a part of the move to Frostbite. And ultimately, we landed on this concept of a layered runtime approach for our future uniforms that very closely mirrored real-world garment construction. And it ended up being a perfect fit for how our reference was already formatted. So we left this initial sort of think tank exercise with a bit more focus, and we started digging into the jerseys and those distinctive panels of fabric that they're made up of. So then we looked at details like the collar, which is a surprisingly complex part of the jersey that can vary depending on the era, the team, and even the manufacturer. Next, we asked, how do we go about stitching those virtual panels together? What kind of stitching would be needed? And this is another case that can vary depending on era and manufacturer. So again, repeating trends here. Ultimately, we did end up coming back to answer pretty much the same question. How can we build this new workflow in Frostbite to achieve better than 4K results and realize resolution-independent authenticity? So next, sorry about that. Next, we set our sights on capturing the tactile quality that the patches, logos, and other branding have that make professional hockey uniforms unique in the sports world. We developed some techniques for generating varied materials and intricate layers of embroidery from that very same source vector art that we pulled from the leagues. It was similar to the approach that we took with jerseys, but distinctly more detailed in its execution. And it was especially distinctive in how important it was to have imperfections be a part of the process of creating this new content. And for those of you that might have been at this morning's keynote, one of the really interesting things that we saw was some of the new tools that the Adobe team had been putting together to help us further express and realize the ideas that we only dreamed of a few years back. This ultimately ended up being one of those rare opportunities for a yearly sports franchise, especially one of our relative team size. I think we're probably a quarter of our FIFA/FC team, as an example. Of course, we didn't do this alone. We were also fortunate to have the experience of those other EA Sports teams that already made the move, and the Frostbite team as well, to help with this massive undertaking. And the support that they gave us, it provided us with the ability to experiment with this increased level of detail that we were wanting to put into our future uniforms. And we ended up having just enough time to stand up a solid runtime concept. So what you're seeing here is one of our first examples that we produced. And really all we did was we just wanted to test the layering and separate out all the pieces. But this is actually in the Frostbite engine, and it was a rapid enough prototype that helped us achieve near production quality results along the way, that gave us the confidence in these bold moves that we were about to make. And all of that was just the warm-up. We had our concepts proven out, and it was game time. So we got to work building our library with 4 key tools. Photoshop, which is where our legacy assets lived. Illustrator, where we'd be doing all of our vector art creation and manipulation. Substance Designer, which became our technical art toolkit for building our library framework. Substance Painter ended up being our artist sandbox for assembling and refining our new uniforms. Dallas is going to tell us how we started to build this.
Yeah, sorry, just before we get into too many of the details as well, some of the reasons why we kind of wanted to build a library for these tools is we run into scenarios like you see on the screen here quite often. What usually happens in hockey is the NHL kind of leads the way when it comes to uniforms, and a lot of the leagues that support them, like their farm team leagues, kind of follow suit. But also leagues from like overseas in Europe, they'll also copy certain things that they tend to do. So we can see a lot of the same kind of panel layouts and materials used and stripe patterns and things like that. And we never really had a great way of storing those things other than directly in the assets that go right into the game. So this is a good example here of the Edmonton Oilers and their farm team, the Bakersfield Condors, that I believe are in California. They're very similar designs here. There's some subtle differences, and those are because they actually have different manufacturers, but they're trying to look pretty much the same, right? So there's a lot of things we can use there. And for the other reasons as well, like when we have a nice organized library, we can scale more effectively. Our content's more organized and easier to find and reuse. It keeps our content more consistent, and it keeps our quality bar much higher because we don't have multiple artists making the same things at varying levels of accuracy and quality. It reduces our effort in general because we're not having to make the same details over and over again. We can just reuse the ones that we made the first time. And these images are a good example of that. So where did we start, and where do we start this whole workflow is we start with vector images mostly. A major base of our library is comprised of vector art. We've used vector art for years, but not really to its full potential. We basically would grab what we need from our reference and bring it into Photoshop and make sure it's the right scale, and then we'd just bake it down and it'd be a rasterized image on a pretty small texture space. So we felt like we could use it a little bit better and really lean into it because it does provide a lot more utility, especially in programs like Designer, where you can use it to generate almost any sort of detail that you need. it's also very scalable just by the nature of it. You can make it whatever size you need, and it's not going to be just pixelated at larger scales. And also, a large majority of our reference is actually delivered to us in vector format, so we already have kind of the source content that we would have needed to kind of move forward with it. Just before Perry here, these are kind of the prerequisites that we go through in getting things into or ready to go into Designer. You can play the video there, Gary. So this is just an example of us taking our reference images and deconstructing and reconstructing it back into what we call recolorable textures or maps. We get 3 zones per map, so we get the red, green, and blue channels. And currently we're supporting up to 5 maps right now, so we get a total of about 15 zones to throw into a design per asset. And then we also need a mask as well to kind of provide something for the entire silhouette of the asset to make sure that when we merge it with other assets that we're only getting what we need from it. And there's some examples here of a bunch of logos. I believe there's some, yep, there we go. There's some examples of how we might lay out our jersey templates into the multiple different zones that we have. And you also saw some normal map details as well, which I'll get into in a second. But at the end of all this, we export all of these maps as SVGs that can be then imported into Designer. And then the last kind of prerequisite part, again, is the normal maps, but this step is kind of optional. We can do this at kind of any point in our pipeline that we choose to, whether it's before we get into Designer, directly in Designer, or later on in Painter. It's kind of wherever we want to put it. But we also had a lot of legacy content that we could harvest and save ourselves some time and effort. And some examples here on the screen are some really high quality resolution logos that we spent a lot of time manually creating embroidery effects and raised and lowered details, some stitching, even their fabric weaves. We did have a pretty good library of that stuff to draw from initially, so we ended up using a lot of that, especially in our first year. And then there's also some things that we didn't necessarily want to rebuild, like stuff with the jersey seams on the side there as well. We didn't necessarily have time to solve for a lot of the techniques that we needed here too in one cycle. We did figure out some methods for like recreating jersey seams, for example, but we found that we just couldn't quite get where we wanted to with the stitching and embroidery with the time that we had. But if you saw the keynote this morning, it seems like the Adobe team has really got some great solutions for that coming. I'm really looking forward to those loops. They're going to help solve us a lot of problems for us for sure. And then we're also currently developing better ways of detailing certain elements of these normal maps, like the raised and lowered details directly in Designer now. That's something that we're kind of transitioning more into material properties. And we could also leverage samplers, embroidery materials as well if we needed to. And I'll just hand it back off to Gary to go back to the Designer stuff.
All right, thanks. So this is sort of our blank canvas of base assets. We started with this because ultimately they're stripped down. They don't really have any material detail. They're really just normal occlusion and cavity maps for representing macro level details so that it doesn't look like a flat mesh. But this is the very foundation that we start building on once we get that content from the art team. I'd zoom in, but you can't see it, but you'll take my word for it. There's no micro detail for fabrics. We strip all of that out as a part of the process of converting everything over. There's really no material considerations or PBR considerations at this point because there's no real tunings to speak of. This is our base. Everything's going to be built on top of it, and we'll be layering that material detail in later. But they do still become part of the library because we need these and all of the other base assets as the foundation of our mix and match sort of workflow that we've developed as our starting point. So while the art team was busy gathering all that source art to create our layers of data, the technical art team was busy designing and building this new framework for the library in Substance Designer. We laid out all the key learnings from our runtime concepts, figuring out how do we hit resolution independence, how do we get vector art into the game, and started to really settle in on some core concepts. But the first and most important one, and certainly the least glamorous, is thinking about scalability. We really needed to work through details of our file structure and naming conventions because we're going to have hundreds, if not thousands, of assets, and we're going to be adding to this throughout the years to come. It's critical when you're designing for scalability. And then we had to also consider how to build this library framework in a way that would be somewhat artist-friendly, since they would eventually be working in Designer along with the technical artists to create all of the various templates. So we start looking at the inputs. Workflow-wise, we opted to link all of our source art for sort of parallel workflow reasons. We envisioned that there would be an artist or a technical artist working on one of these template graphs, and yet a different artist may be harvesting an asset or making updates from legal on an asset. And so by linking, we have this live connection that if one artist updates an asset, then the other artist can sync to the depot and see the changes effectively in real time, and the substance graphs just auto-generate all of that wonderful detail without any mess. We also looked at the incoming inputs as sort of these two elements of raster and vector art. It doesn't really get any simpler than that. We do usually have a fixed resolution for our raster art that's about 2 times bigger resolution-wise than what we end up shipping. And in this case, it's our normal maps. Then we work with our vector art at an 8K scale. Now, we did need to rasterize this data for now. We do have other plans for all that great SVG content we have in the future. But for now, we're going to take it as 8K data and ultimately format it for use as a combination of material, ID, and mask data for downstream purposes. And then this is really the core where everything starts. This is our smart asset parent node. This is the core graph used for synthesizing several passes under the hood using the input data that we feed in. So you can kind of see on the left-hand side, you have a few inputs coming in and many more coming out. This really represents scalability to me when I look at this image. Really what we get out of this is we take all that source data and we're able to generate color data, reflectance, smoothness for all of our material properties, region maps for where we want to tell the different fabrics to live, occlusion for making things feel more connected and believable when it comes time to render later. And then while we're working on this graph, we also have to start giving consideration to the user interface. So we built a custom UI to suit the team's needs based solely on the workflow built inside of Substance Designer. It has so much flexibility for us in terms of logic and control that we didn't find anything wanting. If anything, it became an exercise to figure out where do we dial back to make the artist's lives easier. So we wanted to look at things like limiting the number of vector inputs, because not every design is going to need all of the various zone maps that the art team was going to be harvesting. Some patches might only have 2 of them. We also wanted to make sure that each zone in all of those maps had their own material parameter settings. So for each zone, you'd be able to dial in reflectance, smoothness, cater basically all of your PBR data to best suit the material that you were trying to convey in the end product. And then there were global settings that ultimately we didn't want people to have to touch, but if you needed to, they would affect every layer in the entire structure of the asset. Things like micro-shadowing, there might even be a top-level smoothness for certain asset types, metalness, and which weaves they might want. Additionally, we built all of this with painter usability in mind. Thanks to that interoperability that we mentioned before, we knew that eventually the artists aren't going to be working with the UI in here. They're not going to be setting up these templates they're setting up these templates, but they're not going to be finishing them off until much later. So this is just the start of the UI. And we ultimately decided we need to be able to keep this uncluttered. So we use a lot of the built-in logic nodes to say, if you only have this many nodes, hide everything else. That'll be a great indicator for the artist to basically come in and say, oh, I know exactly how much work I have to do. This one is lighter weight. I know when my work begins and ends, and I can focus on quality instead of being confused about, am I done yet? And then we get to the outputs. We wanted to make sure that we were outputting a payload that would fit multiple needs at once. For visual quality, we needed to ensure that our PBR requirements were being consistently met throughout the pipeline. Oftentimes, this meant actually constraining features like color value range to ensure that we didn't go into PBR unsafe regions, or reflectance to make sure that this fabric didn't go too dark or too light in the reflectance and come off wrong. We also looked at Substance Painter. We needed to know that our library assets would work seamlessly together when they were starting to get layered up, and we wanted familiar paradigms for what would be output at different stages in the graph. And then for the runtime, we needed that exact same workflow to ensure that our substance outputs would work with our game and import flawlessly without any mess. So going a little bit deeper into this graph, we open up, go and explore inside of this smart asset parent, and our first stop was, we're gonna need to make sure all of this is modular. We don't want too big of a toolbox if we don't need it. Simplicity is everything when it comes to these complex systems. So we wanted to structure our graphs in a way that was modular and extensible. Since we had to rasterize our vector art, we started with a pretty standard anti-aliasing pass that we learned from our Adobe training that basically feeds in this 8K map, super samples it down to a smaller size, and then you get nice crisp images that will blend seamlessly once you start using this data as mask information downstream. One step deeper is where things start to get a little bit more interesting, because now we're starting to synthesize additional maps using a combination of built-in custom nodes, built-in and custom nodes for processing the normal data. Then we needed to address how we'd want to parameterize all that vector data that we were feeding in. And we landed on a convention that, again, is inherent in the Substance workflow, color and grayscale operations. These, again, were also done per SVG based on the type of data that we needed to output and supporting all 6 total inputs that we wanted to support. 5 color for all of our zone maps and 1 mask for the SVG. Then this really starts to get down to the core. We used pixel processors to do these atomic grayscale and color operations, ensuring that all of the various variable names and everything that we're using at this low level are consistent and would translate smoothly back upstream where it came time to interface with the user interface. So with our framework in place, we started standing up one of everything: collars, jerseys, pants, socks, manufacturer logos. And we even have a few different treatments of the NHL logo. We have an embroidered version. We have this really cool metallic shield that's actually got this embossed plastic finish on it as well. So we need to represent all of this stuff faithfully, accurately, and have the ability to non-destructively make sure that we're fitting all of these great looking materials into a consistent space. And then by the time the art team got done harvesting all that fantastic content, our framework was basically in place. And so we stood up everything that we possibly thought we could need as far as all of our base templates. And now we're ready to start looking at our weaves. Now these weaves use similar principles that we talked about before, but they ultimately use a simpler structure. We thought it would be easier to roll and customize a fabric pattern from any substance source material or custom created material like a procedural input graph or some image that we found. Like our smart assets, all of these required maps can be generated from a smaller set of inputs, And the output materials can ultimately have as many parameters as the artists desire for control out in painter land once we get these things exported. And since weaves are intended to be simpler and more foolproof, our first pass was going to be much more general purpose. I think we settled on 11 to 13 base materials that initial prototype asset that we were going to build for pre-production. So we started laying those out, picking which substance sources we want to pull from to sort of land on authenticity as soon as possible. But then we also landed on some very specific tunings that we locked in under the hood. Again, this is in the interest of the artist. The simpler their lives can be, the more they can focus on orchestrating masses of content instead of worrying about pushing pixels. It's a very important concept for us on a small team where we've got, again, thousands of assets to produce in a very tight time frame. And a side benefit of all these simpler needs is a relatively simpler data structure as well compared to smart assets. Since all of that color information is actually currently being delivered via our smart assets, we had far fewer parameters, logic, and permutations to consider. So ultimately, creating, rolling up, and modifying our weaves became a much simpler affair. And then this is just a little example of those sort of small collection of initial materials that we created. And we learned a lot in this process just about how different the various inputs could be and how important that was to still capture, because those represent variations, those subtle variations that when viewed at distance really make the different materials blend and contrast from one another really nicely on screen. And now our framework was officially complete. So we had a set of prototype assets in hand, and the art team got to work filling the library.
Yeah, so once we had things all ready to go in Designer, we would export a SBSAR, and then we would store it in our Perforce server. And once it's in there, our entire team can we have tools that notify our entire team that there's new content in the library to pull down if they want it. They don't necessarily have to, but if it's there, if they need it. This includes our internal and external teams because they both kind of use the same workflows and access the same tools. And once it's in the library and they've pulled it down, then it's all accessible right in Painter. And that's what we're looking at here. So these are just some examples of what we've got in there for jerseys, collars, and stripes. And we've got quite a bit more than what's being shown here. It's quite large now after we've had about 2 cycles of work with this new workflow. There's some more examples of more of our weaves and fabric. We're going to be looking at probably expanding this a little bit more too as we focus on other areas of the game. Some examples again of team branding. For these, if you can imagine some teams that you may have seen in European leagues where their whole uniform looks like a NASCAR outfit. You can imagine how many actual logos we might have in our library here. I think it's probably in the thousands pretty easily. And then we also have a large variety of fonts and templates in our library as well. Just from production over the years, we were able to actually pull in a lot of legacy content and flesh out that library pretty full. And then once we have our library, we're directly in Painter and we can start putting things together. But before I get into how we do that, I want to just touch on some of the end of the process. Is once we've got a completed uniform, we then start making smart materials, either at the component level, so with logos that are completed and have been recolored, have had materials applied, or at the full uniform level. We can package up an entire finished jersey, pants, or socks, and those all go back into our library, and that's what we're seeing in examples of here. It's really quite powerful for us because once it means we're not detailing more things than we need to, right? If we have similar looking uniforms and we maybe just need to replace the logos on them, they're already in position, they're already using the right materials and the right panels. It's just about going in and editing colors in a lot of cases. So they provide us a really good base to start from once we've actually got something. There's some things that are a little bit more difficult to categorize in our library, mostly around what we call our vanity content, but we're not really touching on that today. We're mostly focused on the uniforms. But we've got a really great base for our entire library to expand on in the future. So where do we go from there? We can go into Painter, where really everything comes together. Artists are able to work right in context, which has been great for us because previously in our old workflows, we were detailing textures in Photoshop and then going into Maya and having to reload textures or use tools to help us do that. And just the iteration loop was, it was okay, but it wasn't as fast as just doing it directly on the models, obviously. So these are the scenes that kind of make up our payloads for a uniform for both last gen and current gen. So the great thing about the way we've set this up too is that we really just build one uniform and then we kind of export what we need to at the end for where it needs to go. So these are examples of our template scenes for the entire uniform, which includes the jersey, pants, and socks. The one next to that would be our next-gen branding and logos, which get stamped at runtime. And then similar technique for the fonts as well. Those are things that are details that we've been stamping at runtime for years now, and actually provided us a good base to actually get the branding to work in a similar method. And then we have sometimes a helmet logo. It depends on the team design, what they're using. It's a bit more of a simple setup for that one. The great thing too about Painter is just the amount of control we have within the scene. Being able to work on a single layer across multiple channels is just massive for us, because back when we were working strictly in Photoshop, we'd have each channel kind of separated into different groups. And it'd be kind of hard sometimes to find what you're looking for and take more time probably than it needed. So it's great that we can, if we choose to, just work on one single layer and detail out every channel map that we want to at the same time. Yeah, and then kind of how we go about doing this is we usually start with a jersey template, picking that from the library or creating one and putting it in the library. Or potentially we start with a actual finished smart material, and like I was mentioning earlier, and then making changes to it. But generally we start with the jersey because it's the biggest focal point of the uniform. And then from there we pull in all the other elements that design needs, so striping and logos, and we'll start recoloring each zone to match the reference. We'll assign the proper material weaves to where they need to go. And we kind of get a result like the far right image there. And then the rest of it is really just kind of going through all of our channel maps and making sure that all the details are refined and what we're expecting in those maps. One last step that we need to do on the uniform before we are able to kind of move on to the next pieces is we need to define where the stamped elements are, so all the branding, logos, and the fonts. That's what we're looking at here with all these colored boxes. As a shout out to our lead character TA, Eric Medill, and our lead rendering SE, Spencer Krask, for building a custom shader to help us import and export the data that we have been using for this for years is basically stored in XML data. And so what we can do with that custom shader is we transfer all of our placement data from the layer properties of where we've placed these details in the Painter scene, and our custom shader will export and convert that data into something that the game can actually read. And then we can actually dynamically stamp these things, which is really important because especially for fonts, if you think about how hockey team uniforms work, each player has got their own name and number on them. That would be a lot of textures if we had to bake all of those out. So we've been stamping those dynamically for years, and that really provided us a good base to be able to do something similar with the logos, which also allows the logos to show up at higher resolution. And this is where we kind of build out the details for those things that get stamped, is through this branding scene. The good thing about this branding scene too is that we can, depending on how the artist wants to work, we can kind of go in any order that we want to go into. They can detail the logos out in this scene, just save out a smart material for it, and then bring it back into the uniform scene and replace whatever's in there that's probably already got the positioning correct. And then we're just updating certain things that we need to in there. Or you can go the other way around and build it on the uniform and then bring it into here. And then we've got the font scene that we're basically just dragging in our templates or creating a new one based on whatever the teams provided us to build, and making it match the reference for their colors. Some things that teams like to do too is put like name bars on the back of the letters and things, so we end up doing that quite often as well. And then the last one is the helmet logo there, which is really just a color map that gets stamped onto the helmet in a slightly different method. But it's a fairly simple method for that one just because they're usually kind of a sticker, right? And then, so we just got some examples here of what our final payloads look like at the end of this process. This is our last gen payload. You'll notice that some of the sock textures are missing. This is because for the last gen, we have some restrictions on how much we can actually put in the game. So a lot of our sock textures are actually common, which isn't a really big deal, honestly, because we don't necessarily need unique maps for those details. A lot of them are just stripes that get put on. So it's something that works out well with us. This is our next gen payload. You can notice it right away. It's got a lot less to it. And that's mainly because the runtime tiled weaves do a lot of the heavy lifting here. Especially for like the normal and the cavity and micro, our CoF maps, so the smoothness and roughness, reflectance, metalness, those are all mostly handled by our runtime weaves. We do need to export some simpler versions of those maps just for some of the details that, like the jersey seams here in the normals you can see, because that's not something that we can do at the runtime yet. And then we have the branding scene, again, very similar to the last gen payloads from the uniform. This is just because we aren't able to currently support runtime weaves on the stamped elements yet. It's just not something that we've been able to address, but something that we're looking at doing in the future. And fonts, what's great about the fonts is that we can actually share these files between the generations, so we're not necessarily having to create different versions of them for each one. We just may use slightly less maps for last gen versus this next gen that we're now into. And then once everything's ready to go, we've got these awesome export presets that are really a great feature of Painter. It's really convenient to be able to just export our things the way that our engine needs to read them. So we can pretty much just spit them out and upload them right into the engine. We do have a lot of files to deal with as part of this whole uniform payload. So we did have our TAs help us speed up the process by creating a custom export helper that basically just renames and moves files to where they need to go. And that's pretty much it for how we're doing it. So I'll pass it back to Gary to take us home.
Awesome. Thanks, Dallas. So while the art team was busy building all those kits, the technical art team was busy building a new preview tool set that would let us view all of the team's work in the runtime under varied lighting conditions. So through some partnership with our game modes team, we developed the ability to save out and load up entire uniform payloads from our database. We use this for a few critical workflows, like validating the quality of our assets before releasing them into the game, viewing embargoed assets without exposing them to potential leaks to the public, which is pretty important for us because these embargoed uniforms are designed months in advance, and we have enough lead time to design them, develop them, figure out exactly which release or branch it's going to land in, and make sure that it's all done away from prying eyes of people who shouldn't be looking at them. And then we also use them for capturing screenshots for legal approval, and reviewing assets with our art director to ensure that we're nailing the believability and authenticity that our fans are expecting. So this was, again, for NHL 22, and this was developed in calendar year 2021. So since then, we've kept going, though. So we've been working on load time improvements to take better advantage of the runtime hardware so that we can get people into the game faster, and so that these larger payloads and higher fidelity payloads don't slow the experience down. And like any other release, there's bug fixes to work through. We have workflow tweaks because we never quite get everything perfect, even though we're really happy with the results. And then we're always striving to improve our lighting and rendering so that we can deliver more diverse and believable materials to our players. And everything that we talked about was only for our authentic league uniforms. We still have more apparel that we want to give this next-gen treatment to. We have Creation Zone, which is where our competitive players build their fantasy franchise teams. We have World of Chill, which is a casual online mode where players can craft a unique individual look. And we've also got other ways that we're exploring, let's say, for players to express themselves, and we can really only tease you with it right now, unfortunately. But going forward, what's really great is the team is armed with all of the learnings from the last 3 years to help us get to where we want to be faster. We're incredibly excited for what the future holds. And we want to close in thanking EA and Adobe for giving us this opportunity to share with the community. And we want to thank everyone here tonight for actually coming out and spending your time with us. Thank you very much. And we do have some time for Q&A, so if anyone wants to step up to the mic and ask a question, go for it. Hi.
Hi. It sounds like the process that you're describing is largely offline, or in other words, you're baking out textures and then importing them into Frostbite. And I'm wondering if you've experimented with substance runtime, or that is importing the SBS files into Frostbite and using the live ability to edit.
So the question is, are we taking advantage of the substance runtime to help deliver these payloads?
I know that you're not in what you've described.
Right.
But
right, yeah. So, yeah, it's interesting. It was something we investigated early on, and without going into too many details, it was something that we just didn't have the time or the flexibility to pull off in that tight deadline. Part of the challenge with a lot of this is what we described was just a fraction of what the team was doing, and it was a tremendous effort. There were similar endeavors going on, and ultimately our capacity for doing new things can only go so far. So this is sort of where we drew that line, and we weren't really able to dig any deeper than doing some really early experiments with it. Thank you. It's hard to see through the microphone. Yeah. All right. Well, if no one else has any other questions, thank you very much. Have a great evening, and thanks again for coming out. Really appreciate it. Thank you.